Welcome to this introduction to the Duplicate Replacer app for Autodesk Inventor. We're going to be covering what's the problem with duplicates in Inventor and how does the app solve the problem. Secondly, a quick demonstration how to replace duplicate components in your assemblies using the app in the minimum number of button clicks. And thirdly, we'll do a deeper dive. The app does include some review tools to help you manage and diagnose duplicates in your assembly in addition to actually replacing them. And then towards the end of this demo, I want to cover an alternative powerful tool in the app, which is the ability to take advantage of the Inventor bill of materials merging on part number iProperty. The app does allow for automatic replacement of these iProperty values, and we'll look at the pros and cons of that versus replacing the components themselves, so you can establish which might be best for your workflow. And then finally, frequently asked questions about the app to hopefully demystify how it works a bit. So let's head over into Inventor and take a look at this example roof assembly we see. It has been modeled using the multi-solid body workflow in Inventor, which is probably the workflow where you're most likely to end up with duplicate parts, because of course every solid body in the master part ends up as a unique single part file in the end assembly, which is what we have here. The Inventor community has come up with several creative workarounds to the problem of duplicates we have here. For example, on this assembly, these beams could probably be patterned in the assembly based on the feature pattern in a part file. And sometimes you can try and place multiple copies of components in the assembly and constrain them in place one by one. This can be either too limited or too manual, sometimes simply too unpredictable as an operation. For example, in a case like this assembly that we see here, the task becomes much more complex. It's simply not clear which parts are going to be duplicates. When you consider left and right-handed features, different part orientations, small drillings on the parts, etc., etc., it can become a pretty daunting manual task. And one of the workarounds, even relying on the volume of the part in the bill of materials, can also be misleading, of course, in these scenarios and can cause mistakes. So without a dedicated tool to handle this, companies often end up simply leaving their assemblies containing the duplicates, and all the downstream operations will be negatively affected by that. For instance, your drawing documentation, your cut lists, even your file management, because in this situation you're then managing several duplicate IPT part files on your system where you could actually be managing one. So we thought that it was time for a dedicated solution to this problem, which is where the duplicate replacer comes in. But hang on, quick question, didn't Autodesk tackle this problem recently with the tool introduced in Vault 2020.2 called the Vault Search Duplicates tool? Well, yes, they did, and it's a fantastic tool, but we believe it only solves half the problem. The Search Duplicates tool in Vault can check whether the parts in your assembly already exist in the Vault and replace them from the Vault. And it is a great tool for keeping your Vault and your legacy part library as lean as possible, and remove duplicates from your Vault, from your library of parts. However, being able to check your parts against the Vault is only half the story, because what if you have duplicates in the active assembly, which we do here, or we believe that we do here, and you need to remove those duplicates first? The Vault tool isn't designed for this scenario, as you'd only you would need to check the entire assembly into Vault first, so that it can then be indexed by the job processor. So you've got to wait for the Vault job processor to scan the files geometry, which can take a while. Then you need to run the duplicate search and replace the files one by one in this assembly. It's not designed for bulk batch replacement as this tool is. And then you've loaded all the files into Vault, so you have to clean up the now redundant files in Vault and remove them out of Vault. So there's several steps there. It's not really a process the Vault Search Duplicates tool is designed for. So we believe the duplicate replacer is a very good complement to the Vault duplicate search tool if you are using the Vault tool, because it's the perfect tool to clean up your assembly before using the Vault Search Duplicates tool and checking it into Vault. So check your assembly against itself for duplicates first with the duplicate replacer, and then once it's clean with respect to itself, you can then check it against Volt using the Volt Search Duplicates tool if you've got a new enough paid version of Volt. And we're not aware of any other alternative to the duplicate replacer app at this point in time to meet this need. Okay, let's do a quick demo of the duplicate replacer on this example assembly we've been looking at. Let's just quickly take a look at the bill of materials as it currently stands. So we've got 115 unique, total occurrences in this assembly. And if I look at the bill of materials, then because we have one part file for each solid body, we do unfortunately here have 115 rows in the bill of materials, and the quantity for each of those is 1. So if we do have duplicate parts in this assembly, they each have their own unique part file for us to manage, hence the reason for the app. So let's just close the bill of materials and let's bring the app into play here. So we can access it from the Scan Assembly button up on the Quick Access toolbar, or from the Inspect tab, Scan Assembly. So let's hit this button and the app's going to scan all the parts in the assembly in this case and build us a list of groups of duplicate parts. We can see actually here, if I select all these rows, each one of these rows represents a group of duplicate parts. We can see as I select them that those parts are highlighted. We can see if we select them all, by right clicking select all rows, we actually have 22 groups of duplicate parts in this assembly. Now I promised you this was going to be minimum number of button clicks, so one click to run the scan, another couple of clicks to select all the rows or all the groups of duplicate parts, and then I can simply right click and replace parts for all of the 22 groups of duplicate parts. Now I know there's probably questions you have at this point, but let's just hit the button, let's replace all those components. We're going to be replacing 92 component instances. So I'm going to say yes, and these components, 92 components, have been added. We then have a review stage where we can check whether we're happy with the component replacements. If I look at that, this assembly does look the same. That's because the new proposed replacements have been added on top of the original parts. So we'll look at some review options afterwards in a slightly deeper dive, but for now all we need to do if we're happy with these proposed replacement parts is to right click and accept them. We can discard them as well, but in this case we're just going to accept them. The original parts are going to be deleted and we now have 92 active replacement parts in this assembly. So we can see here the total number of occurrences in this assembly is still 115, and the proof of the pudding is in the bill of materials. So if we go into the bill of materials now, we can see that if I just renumber this, we can see that we now only have 23 unique parts in this assembly, and they all have quantities relating, well, most of them, I think all of them, have quantities higher than 1 because these parts have been placed in multiple locations in this assembly. So this hopefully looks as you would expect it to. You can see the multiple quantities of these parts, and we now have a streamlined bill of materials that is suitable and ready for a streamlined manufacturing operation, ready for production. Okay, so far so good. You can see hopefully that it takes maybe 8-9 clicks to replace the entire set of duplicate parts in an assembly of any size. Multi-solid body assembly, any kind of assembly in fact. But of course there are still probably some unanswered questions in your mind. For instance, how do we know which part file in a particular group of duplicates will be actually used to replace the others? Can we change that if we want to? Why did we have a review step, if I can say the word, before accepting the replacement parts? So let's look at the process again, look at some of the tools we can use to review, and look under the bonnet a little bit at what's going on with the replacement. So I'm going to close this assembly without saving, and I'm going to open it again in its original unreplaced state. So let's run the app again. This time I'll run it from the Quick Access toolbar. Again, we're scanning the entire assembly to build a list of groups of duplicate parts in this assembly. So again, we've found 22 groups. This time I want to show you some of the tools we can use right at the start here. So if I click on a particular group, let's say this group, it has 8 part files in this group of duplicates. Let's look at how we could see some more information about those part files. I can hover over the thumbnail here and I can see that's part file 1 of 8. I can see the file location of that, and then I can click on this thumbnail and see the other 7 part files, this thumbnails for the other 7, and keep on looping around and see the file locations. So that's one way of seeing which files are contained in this group of duplicate files. Any one of those I can actually open. So if I'm particularly interested in part file number 2 or 3, I can click on this open button here. That will actually open that part in a separate window and I can take a look at it. This is actually, of course, only opening the part in its own window. If I want to view all the parts side by side, there's another tool for that, which I'll show you in a minute. But another way to take a look at all the part files contained in this list of duplicates, to check that we're happy with it, is to hit the expand button here, and I can then see a detailed list of each of the part files contained in this group. So I can see I'm in group 8 and there's 8 files contained within it, and I can see that they each have a quantity of 1 in there. That could of course be multiple occurrences of the same part, and we would be able to replace all of those if we wanted to. And here we come to another option tool in here, the ability to change what the source part is for this group. So at the moment we're saying this file, glass3h.ipt, is going to be used, when we come to replacing, is going to be used to replace the others in the group. If we say, well no, actually I want glass3d to be used to replace the others, all I have to do is to right click and make it the source part. Okay, and this part is now specified to replace the others when we come to the replace operation. We can open the files directly from this these buttons here as well, and we can of course view the thumbnail and open them from there too. So this is the detailed list, and we can also isolate the part files here, but we'll come to that in a moment. So I'm going to return back up to the group view, and you can see the change I've made here. The source part, the part that's going to be doing the replacing for group 8, is now part 8.5. The default is to be the first part in the group, so that would have been 8.0 there, but we've changed that one. Worth mentioning as well that in the group view we can choose what the source part is going to be for a particular group. So if I click on this this group of part files here, I can click on this icon here to choose a new source part for it. So if I click there, these are all the parts in group 4, I think it was, so I can have a look at them and I can say, okay, I want to pick this one here. I've now picked part 4.5 for group 4 as the source part. So we have that level of control. So previously I mentioned, what if I want to view these supposed duplicate parts side by side in order to convince myself that they are in fact actually duplicates? There is a way that we can do that. Let's select as many groups of parts as we want. So I'm going to actually select all the rows, and then I've got a right click option to create an arrangement of whichever groups of parts I've selected. So I've picked all 22, and if I hit this now, it's going to create a new temporary Inventor assembly, and it's going to lay out all of the groups of duplicate parts for me in rows. So you can see it's put them in folders as well, group 1, 2, 3, 4, 5, 6, and so on and so forth, and it's just laid all these groups of parts out for me. So I can, I can see the contents of these folders if I want, and do anything I would normally do in an Inventor assembly, but it just gives me the opportunity to look at these parts side by side and see, okay, these are 2 different part files. Are they actually the same as each other? Am I happy and ready to proceed on the basis of these parts being the same? So hopefully you can see that these are the same. These are identical parts, even though they're different IPT part files, and they're in different orientations with respect to them to each other in the assembly and within the part files themselves. This, I can't think of any other use for this assembly other than as a sort of review tool, but perhaps you can find a use for it other than that. But when I'm happy with that, I can close this this assembly. It hasn't been saved, it's not saved on disk or anything, it's just temporary, and I can think about proceeding with the replacement operation. But just before we do that, I want to just show you a couple of the filter tools in here, because this will help explain what's actually going on. So if I've got all of the groups selected, I've got 4 filter buttons at the top here. The left hand side one will turn on every single part in this assembly, or the parts that were already on when I started the tool. This button second along here will only show me components that do actually have duplicates, so I'm only looking at the duplicate components in the assembly now. But these 2 buttons on the right here are probably the most interesting. This will show me, if I click this third button along, it will show me only the components that are marked as source parts. So these are the components which, if they're placed in different orientations throughout the assembly, can actually create the entire assembly just with these parts. And the other button along here is the parts that can be replaced by those parts. So you see, if we have a combination of those two, we've got the whole assembly. So here's the source parts for the replacing, and here's the parts that will be replaced, or if we go ahead with the replacement operation, source parts, replaceable parts. Okay, so if I leave the only the source parts on, and we actually run the replacement, we should see the assembly being built up of just these parts being placed in different orientations. So I'm going to right click and say replace parts here, and I get the same prompt. 92 components are going to be placed, so I'm going to say yes, and we can see it building the assembly. This is a good point now for us to look at what we can do as part of this review stage, because if I just click off of here, we're now at a stage where we've got more component occurrences in the assembly than we did originally. We started out with 115, we've now got 207, because we've got the replacement parts on top of the original parts. We haven't yet accepted the operation and deleted the originals. We can see we've got a different icon for each row, each group of parts where this is the case. Of course, we could have done this with only 3 rows, but we happen to do it with every row in the collection of duplicate parts. We can also see, if we scroll down here in the assembly tree, we've got underscore replacement parts. If I hover over them, you can see they are placed on top of the original parts. So this is a good, again, another good review tool for you to check. Worth mentioning at this point, these replacements all happen to be in the top level assembly at the moment, but a frequently asked question would be the replacements. Do the replacements happen in the sub-assemblies? If we do have sub-assemblies, and the answer to that is yes, the components will be replaced in the same assembly which they currently exist in, no matter how deep in the assembly it is. So we're in this in-between phase where we've got the replacements and the originals, but when we're happy, when we've used whatever review tools we want in here, we can go and proceed. Let's just briefly look at the detail view, because this helps to explain a bit what's going on as well. Let's look at the these files here, because this is a nice simple example. If I look in the detail view here, what I can see is that I've actually got 12 of the source part in here, which makes sense because I've placed another 11 copies of it, haven't I? And then I've got the original part files here, which are ready to be deleted. Now I can actually delete those straight from here by hitting this delete button, but in this case I won't do it. I'll do it all in bulk. So let's return back up to the top level group view, and let's select all these rows, and let's accept. We're happy that these parts have been placed in the correct locations. They're in the right sub-assemblies if that was relevant, so we can right click and accept the replacement parts. So when we do that, the original parts are deleted and the new components are renamed. So if we look in the assembly tree, they're no longer called underscore replacement. They have the default names according to their part number iProperty, however you've got it set up. And if I click off of that, we can see we're back down to 115 unique component occurrences in the assembly. but of course, 115 total component occurrences in the assembly. But of course, now if we use our filters, show me only the source components in this assembly, that's all of them, because we've put the source components everywhere in this assembly now as replacements. If I look at replaceable components in this assembly, there are none, because we've finished. You can see the icon here, the finish flag says all duplicate parts have been replaced for this group. So we don't have to do it all in one go. We can do different rows at different times, and you'll see the different flags for what stage you're at. Another thing which helps to make the point here is if I was to run another scan on this assembly, so if I scan the assembly as it currently is, let's just turn on all the parts so we can see we've got something in this assembly. If I was to, let's turn on everything, if I was to run another scan on this assembly, what we will see is that we don't actually have any duplicate part files in this assembly anymore, because they've all been replaced. Okay, and the bill of materials, as we saw before, is now correctly merged. We'd have to renumber this, same as before. Okay, I wanted to just cover briefly an alternative to component replacement that the app does actually provide a tool for. This is if you don't want to restructure your assembly for some reason, you want a lighter alternative to merge identical duplicate parts in your bill of materials. We can take advantage of the fact that Inventor automatically merges items with the same part number iProperty in the bill of materials and recognizes them as effectively the same part. You could say an advantage of doing this over component replacement is that it doesn't involve assembly restructuring, and so it can be performed at any stage in the design process. A weakness in simply replacing the iProperties is that you will still have many duplicate part files existing on disk that actually represent identical parts. And also worth mentioning, for users of the Woodwork for Inventor add-in, iProperty replacement won't be suitable for you if you're using the Woodwork bill of materials, because the Woodwork bill of materials does not merge on part number iProperty, unlike the Inventor bill of materials, so you will have to use the app to replace the components themselves. So we need to take a look at the bill of materials before we start to improve it with the duplicate replacer. So let's take a look at the parts only bill of materials. If we scroll down here, we can see that we've got 99 rows in this bill of materials, which means that we've got 99 unique part numbers, part number iProperties represented in this assembly. We can see that some of these parts are placed twice or more in the assembly, but we think we can reduce the number of rows in this bill of materials by merging with the app. So let's find out if we can reduce that from 99. So let's run a scan of this assembly and see how we could use this part number replacement tool. So I'm going to scan the entire assembly. And there's two methods that we can use for this. Let's just resize this a bit. If we're not too concerned about which part number is actually assigned to all the parts in a particular group, we just want the part number to be the same and for them to merge, we may be okay to just merge the part numbers from the top level group view that we have here. And if we do that, then the part number in the source part for each group, which is by default the first part in each group, will be written as the part number to all the other parts in each duplicate group. So this is as simple as selecting all the rows, noting at the moment the part number for each group varies, it's not consistent within the group, and I can just right click and say replace the part number iProperties. So if I do that, we've now replaced the part number iProperties, and we can see that the part number is consistent for every part within a particular group. And if we take a look at group 1 here, for instance, we can see that we have got 3 part files in this group, and they've all got the same part number of BDR bumper 1. If we had right clicked beforehand and made this part the source part, then we would have the part number for this part being written to all of the parts in the group. So that's the quickest and easiest way if you're not too bothered about which part number gets written to each part file in the group. If you are more concerned about that and you want to check and ensure what exact part number is going to be written to each part file, what you can do is you can enter each group here. So if I go into this BDR bumper group, then what I can do is simply just edit the part number inside here. So let's just say that I want this to be called bumper version 2, for instance, if I can spell that correctly. Then what I can do is I can write this value to every other part in the group. So I can simply just click this button here and that will update the part number for every part in this group. So having completed this operation, we can now close the duplicate replacer and we can check the bill of materials. And if I renumber this, we can see that we now have a total number of 75 rows instead of 99. We can see that actually some of these rows have definitely been merged because the description iProperty now varies for all the parts in the group, which we have here. So it's a possible future enhancement for the app. Let us know if this is of interest to you. We could allow the option to also merge and replace other iProperties other than the part number one, so that the description could be merged, stock number, other properties like that. So let us know if that's of interest to you. Of course we can just select it here, I think, and we can just make a change in here to multiple parts in one go. Okay, so if you've made it this far in the video, you've quite possibly got some questions that we haven't covered yet. So some frequently asked questions about the app. Does the app only work on assemblies made of multi-solid parts? And the answer to that is no, it works. It's designed for any assemblies. It's probably going to be most frequently used on multi-solid part ones because there's more duplicates in them normally. But we've tested the app on assemblies like this trusty Vimic model here, which happens to only have five groups of duplicate parts in, which is interesting. So well designed there. And also a slightly more extreme example with this production line, which happens to only have 6 groups of duplicate parts in it, which is also extremely impressive. But yeah, this assembly's got 5,500 parts in it in its current build. It can have even more in a different level of detail, but the app will run fine on assemblies of this size with no issues. Question 2, what about sub-assemblies and what about constraints? So let's head back to our roof assembly and also the light theme in Inventor 2021, and let's look now. I've demoted 3 of these glass components into a sub-assembly. I've also constrained 2 of the glass components together, so we can see what happens to these subcomponents and constraints when we replace. So let's run the scan. Another thing I can show you about the scan here is if we pre-select components, the scan will only look for matches of those components that we've selected. So on large assemblies this can be a handy way of doing a limited filtered search. So let's just pick this sub-assembly and say we're only really interested in duplicates of this, the components in this sub-assembly. So you can see we're scanning against only selected components there, and as expected we have a group of duplicate parts, some of which are in this sub-assembly, and so what we can do now is right click as before and replace the parts and say yep, we're happy to replace 11 parts here. And as we look down here, what we can see is, if that's clear at all, what we can see is that we do have 2 replacements within this sub-assembly. So this component here and this one here are replacements for this one here and this one here, and they are in the sub-assembly. Okay, so the original components are still there with their constraints, but when we right click and accept rather than discarding the replacement parts, so we can forget the operation here and cancel, but if we accept that, you'll see these 2 components here being deleted. So let's accept that, those components are deleted along with their constraints. So the constraints aren't a problem, but they are just deleted, and the replacement components are grounded. So you see these other replacement components, they're all grounded in the assembly. Which brings me to another frequently asked question, which is, what about if I want to make changes to this assembly after I've done some replacements? Or what about if I change my mind after I've done the replacements? Well, in this initial release of the app, changes after replacements are not supported. So this can be added as an enhancement for the app in future. We'd love to add that feature. So let me know if this would be useful for you or your company. At the moment, the replacement operations need to be run. The app needs to be run at the end of the design process. So possibly, if you prefer, on an issue to manufacture copy of the assembly. So you can use any of the copy design tools that are available with Volt or without Volt to do that if you prefer. If you're not sure if you're going to need to modify the source assembly afterwards, you're not sure if there's going to be later changes. One more tool I wanted to show you here before we go is if I close this assembly and reopen it. We've got Find in Browser tool and also Find in Table tool. So let's run this scan again. If I'm not sure where a particular component is in the table, but I want to select it, but I don't know which group of duplicate parts it's in, there is a way of doing that. So if I want to know which group of duplicate parts this part is in, for instance, how do I do that? Well, I can do it by using this Find in Table tool. So if I pick this, I need to pick a component. So if I pick the component I'm interested in finding the group for, then it will find that group in the table for me. So I selected a part in group 18, and then I could do something with this group, like look at the detail view to see how many occurrences we have and so on and so forth, or replace them. So that's the Find in Table tool. I've also got the Find in Browser tool, which is very useful on larger assemblies because of course they may have a very deep assembly structure, and it might be difficult to find where these parts are in the assembly tree. So what we can do is select any group or groups of parts and right click Find in Browser, and that will then highlight in the browser and expand, if they're collapsed and hidden at the moment, the components in the group that we've selected. Okay, that's all I wanted to show you for the app. I hope you find this enjoyable, and get in touch. We'd love to help you out with it.